All right, guys, so we are going to talk about section 3.5, which are zeros of polynomial functions. And the zeros of polynomial functions are very similar to what we talked about with our zeros and roots of quadratic functions. So again, we're looking at x-intercepts and x-touches. So the essential question that we're looking at right now is how are the zeros of polynomial functions related to an equation and graph of that function? So today, the two objectives that you're going to have is that at the end of this Edpuzzle, you will be able to identify the zeros of a function by factoring or using synthetic division. You will also be able to use the zeros to sketch the function's graph. So the first thing we're going to do is we're going to factor and graph this equation. So when I look at 4x cubed plus 4x squared minus 24x, I see a common factor of 4x. So when we factor that out, we end up with x squared plus x minus 6. Now when we look at that, we should be able to see that this is something that can be factored. And we can use our x. We're going to multiply a times c. That's negative 6. Our b is 1. So when we factor this, we're going to end up with 3, negative 2. Because 3 times negative 2 is negative 6. 3 minus 2 is 1. So we can factor this out, and we end up with 4x times x plus 3 times x minus 2. Now remember, we set these equal to 0, so we're going to have 4x equal to 0. We're going to have x plus 3 equal to 0, and x minus 2 equal to 0. So this becomes x equals 0, x equals negative 3, and x equals 2. So as a result, we are able to take this graph now and we're able to plot those zeros. Those are all of our zeros. So we have one at negative 3, we have one at 0, and we have one at 2. So we also know that this is a x cubed, so we know that this, and it's positive, so the coefficient 4 is positive, so we know we're going to have our S shape, so we're going to have something that comes up here, goes down, and back up. So between the zeros, which we know are the x-intercepts, and the first term, where we have a positive coefficient and an odd degree, we're able to draft the rough draft of the graph. Now, we haven't talked about certain parts of it, but that's the general shape. So what if we have g of x equals x to the fourth minus 81? So again, we're going to factor. So when I look at this, I want to use our polynomial identities. So I look at this as x squared squared minus 9 squared. So I look at that as a difference of squares, right? So now when we look at this, we're able to say we have x squared plus 9 times x squared minus 9. Remember, that's the difference of squares equation and identity. So now we can again break these down. So this one, using the same difference of squares, is going to be x plus 3 times x minus 3. So right here we have x's of 3 and negative 3. So we know that we're going to have x-intercepts at negative 3 and 3. Now we also know, like if we set these to 10, actually 20, 40, 60, 80, we know that our y-intercept is going to be negative 81. Now remember, when we look at this one, this is where x squared equals negative 9. When we take the square root of both sides, we're going to get an imaginary number, right? So because we have an imaginary number, those ones are not going to be plotted on this point. So we have an positive leading coefficient. It's 1. We have an even degree, so it looks like a parabola. So we're able to say that the general shape of this graph looks like this with those x-intercepts at -3 and +3. So see, by factoring, whether we're using our identities or we're using our old factoring tools, we're able to find the x-intercepts, which tell us the zeros and x-intercepts that we're going to be graphing. So here's a new element to this, though. So how does a multiple zero affect the graph? And what we mean by a multiple zero is what happens when we factor this and we end up with something that looks like x minus 2 squared or x minus 1 cubed. If that's one of the zeros, how does that affect the graph? So this is called the multiplicity of a zero. We're looking at the degrees of these. So when the multiplicity of 0 is odd, okay, so 1, 3, so this one right here, 3, then the function crosses the x-axis. So when we look up here, these were all 1s, right? So because they're 1s, they cross the x-axis. On the other hand, when the multiplicity of a 0 is even, then the function has a turning point. At the x-axis. So in that case, instead of crossing the x-axis, then if we had, for example, our x minus 2 squared, we know that's x equals 2. So at 2, the graph would touch and have a turning point. So that's the key here. When we're looking at this and we're factoring it, if the 0 has a multiplicity that is odd, 1, 3, 5, 7, 9, then it's going to cross the x-axis. However, if the multiplicity is even, squared to the 4th, to the 6th, to the 8th, then the function has a turning point at the x-axis. So it's going to touch the x-axis and return the way it came. So when we look at that, for example, we look at the function f of x equals x times x plus 4 times the quantity x minus 1 to the 4th power. So this means that x equals 0, which is right here. It's an odd multiplicity. It's just 1. So it crosses the x-axis. So x plus 4 is going to be x equals -4. It's to the 1st power, so it's also going to cross. However, x minus 1, which is x equals 1, so at x equals 1, it's an even multiplicity because it's raised to the 4th power. So because it's raised to the 4th power at x equals 1, then this is going to only touch the x-axis. So for this, at -4, it's crossing. At 0, it's crossing. But at 1, it's going to touch and come back up. Now, we don't know, because we haven't multiplied this out, what the shape of the graph is or how it appears anywhere else. But generally speaking, we know at those points, there's going to be intersections here and here, and there's going to be a touch at 1. So what about this next one? So for this next one, we have x minus 1 to the 5th power. So that means we have x equals 1, and it's an odd power, so that's going to be a cross. We have x plus 2, so at x equals -2, we're going to have a touch because we have an even power with the 2, even multiplicity. Now remember, x squared plus 9, we talked about it up above. That's an imaginary number, so those aren't going to be x-axis points because this becomes x squared equals -9. That gives us x equals 3i, plus or minus 3i. So remember, those aren't going to be on the x-axis. Those aren't going to be on the coordinates that we normally do. That becomes the third dimensional element. So because of that, we only have these two x-intercepts. One is a touch at -2, and one is a cross at 1. So now if we're given a graph, so we have this graph here, and we're given this, and we're told that we want to find all the real and complex zeros of this graph. So the first thing we can do is we can see we have 1 0 at x equals 2. So that's definitely one of our points. And we know that that is going to be a factor because it is a 0. So now we can divide this function that we have here by x minus 2, right? Because we know here the factor is x minus 2 equals 0 because we subtract 2 from both sides. So we have x minus 2. So let's set this up in synthetic division. So we're going to have a 2 on the outside because it's the opposite of our x minus 2. And then we're going to use the coefficients here. So we have 1 because of the x cubed, 1 because of the x squared, -3 because of the x, and -6 as the constant. So now we're going to use our synthetic division process. So we bring the 1 down, we multiply 2 times 1, that becomes 2. Add that together is 3. 2 times 3 is 6. Add that together, we get another 3. And 2 times 3 is 6. When we add that together, we end up with 0. So again, our remainder is 0, so we know x minus 2 is one of our factors. So now we can rewrite this, right? We started with an x cubed, so we know this is going to be x squared plus 3x plus 3. So we now have x minus 2 times x squared plus 3x plus 3. Now, can we factor easily x squared plus 3x plus 3? I don't think so. So because of that, we need to use the quadratic formula. See how this all starts to fit together? So we're going to use the quadratic formula here where a equals 1, b equals 3, and c equals 3. So we're going to have negative b, that's -3, plus or minus the square root of b squared. So that's 3 squared, that's 9, minus 4 times a is 1 times 3 is c. All over 2 times a, which is 1, is 2. So that becomes -3 plus or minus the square root of 9 minus 12, all over 2. So that's the square root of -3. Remember, we can always break this down to the square root of -1, which is I, and the square root of 3. So we end up with -3 plus or minus I square roots of 3 all over 2. So those are 2 of our zeros, right? That's what we use the quadratic formula to find the solutions. So x's are going to equal -3 plus or minus I square roots of 3 and 2 over 2. And x is going to equal 2, which we found originally. So those become our zeros. Real, which is 2, which we see right here on the graph, and the complex by solving. So you can see how this is twofold. We read the graph, we find the 0, we then divide our polynomial by one of the factors. Then because we have a quadratic, but we can't factor it, we use the quadratic formula to find the solution. So this can be used, this process is used throughout. So another way to do this is to find the zeros. So what if we were going to find the zeros of f of x equals 4s to the 4th minus 17s squared plus 4. Now when I look at this, even though it's s squared and s to the 4th, I look at this and see a factoring by grouping type of problem. So when we look at this, we can take our a times our c, that's 16, and our b is negative 17. Well, this one works out nicely. So our factors are negative 16 and negative 1. So we're able to break this down into 4s to the fourth minus 16s squared minus s squared plus 4. So when I look at this, I can factor out a 4s squared from this first one. So when I factor that out, that's going to leave me with s squared minus 4. Now I'm going to factor out a negative 1, which is going to leave me, again, with s squared minus 4 over here. We have that as a common factor, so we have 4s squared minus 1, right, from these, times s squared minus 4. So now we can solve both of these, right? So if we set both of these equal to 0, we get 4s squared minus 1 equals 0, and we get s squared minus 4 equals 0. So we can add the 1. So that leaves us with 4s squared equals 1. Divide both sides by 4. Now this is a fun little trick because we get s squared equals 1/4. When we take the square root, what times what gives us 1/4? It's different because it's fractions, so we're going to get s equals plus or minus 1/2. And then we're going to get here, we're going to add 4 to both sides. That gives us s squared equals 4. Take the square root of both sides. That gives us s equals plus or minus 2. So as a result of working this through and finding the zeros using factoring and grouping, we're able to determine, even though this is s to the fourth, that our solutions are going to be s equals 2, negative 2, 1/2, and negative 1/2. And those are our solutions. So I recommend now that you guys go to a graphing calculator or Desmos and graph that and see if those are each of the x-intercepts for this graph. So as you can see, as you work through these, you're able to take the information that we have from these graphs and you're able to find the x-intercepts or the turning points, depending on the power to which the factors are raised. We can then do a rough sketch of what these graphs look like. We can also take polynomials and factor them using our synthetic division or long division or any other process that we have, and then incorporate things like the factoring by grouping, the quadratic formula, even potentially factoring or completing the square in order to find additional zeros. We can then use those to plot them on the graph and find our solution. So come to class tomorrow with any questions you have about any of this, and then we're going to work on some additional practice problems in class. I hope you guys have a great night.